We're now going to calculate the mean absolute deviation and the median absolute deviation. You would take each data value and subtract it from your mean that you calculated, just the regular mean, and then take its absolute value, just the positive number for that. So you can do that in your calculators. I'm going to do it here in Excel, where I would say I want that data value in there to be that minus the mean, 90.1. And I want this to be the absolute value of that. So in your calculator, you just put it in, then you just take the positive number, and you do that for each of these. Once you have that, you're going to take the sum of that column, so you would just add that in your calculator. And there I have the sum of my absolute deviations. Now I want that average, that mean absolute deviation, so I'm going to take that number and just divide it by n. There's the number right there. Now we're going to look at the mean, the median absolute deviation, and how we would do that. So for the median absolute deviation, we're going to first sort our data out. So we've got to do a data sort on this. So the first thing we're going to do is sort our data. So I'm going to take the data, I'm going to copy it, put it where I want it to be sorted, and now I'm going to take that and do the sort on that. I'm going to highlight that, go into sort. I went from smallest to largest, and I don't want to expand, I want it right on the selection, and now my data is sorted. Now I want to take that sorted X and subtract it, excuse me. So I go in and I calculate the median, and with it being sorted, we know that it's going to be 90 plus 91 plus 92 divided by 2 to give us the median of 91.5. So now I have to take each of these X's and subtract it from 91.5 and take its absolute value. So I would say, in here, I want the absolute value, equal the absolute value of that minus the median, which is 91.5. And I'm actually writing it in there because if I tapped onto this cell down here and did it and dragged it, it would change to these and I'd get undefined. And if I wanted to have this remain constant, well, I can show you. Let's say that I went in here and instead of writing the number, I actually tapped that and did this and said equal. I'd have this, but when I drag this down and I try to copy it, what happens with this is I now have, and I'm doing H3 minus, that's H3 minus H14, but H14 is a 0 in there, so you're going to start getting the same values as you're doing that. So what you need to do is, if I wanted to do this, I would have to, because I want that cell to remain constant, I would have to put a $sign here and in front of the 13, and that makes that value remain constant for all the absolute values. And I could go down, and now I can copy all of those and have that absolute value of those. And now I need to sort that data and find the median of that. To paste the values, and now I can take this and sort it from smallest to largest, and now I'd have to take the middle two here, which would be these two, so the mean deviation would be 3.5. And there you have how to find the median average deviation. So the steps again is I take my X values and I sort them, then I have to find my median, which, remember, the median is the average of those two middle data values. So the median would be 91.5. Then I take 91.5 and I subtract it from each of these values here and take its absolute value. So I have that. Then I want to sort that column and find the median of this column, where the median of this column would be these two. And of course, the average of those two is just 3.5. So that's how you find your median average deviation. So now I want to go over how to find percentiles and or quartiles. Suppose that you have data. The data goes from one data point all the way to the n data points, and we want to find the, let's say, the 20th or the 30th, or in other words, the pth percentile, a percent of data that is less than or equal to that data value. So this is how you would calculate or compute the index of that particular percentile. We say that kth is the index of that percentile. So we would take n, which is the number of our data values, times whatever percentile we're looking at, 20, 30, or 40. So we'd say 40 and divide by 100. If k is an integer, the pth percentile is going to be the mean of that index plus the next greater data value index-wise, the average of those two. If it's not an integer, then we go to the next greatest integer. So here's a couple of examples to explain what's going on here. So suppose we have 41 ordered values and we want to know the 12th percentile. Our data, the number of data values is 41. We're going for the 12th percentile, so p is 12. In order to find the index of my 12th percentile, I would use the formula 41, that's the n, times the p, which was 12, divided by 100. I get the index of 4.92. Since it is not an integer, I go to the next greater integer, not rounding rules, but to the next greater integer, and so therefore my index would be in the 5th position. Let's look at another example. Suppose we have 41 ordered values and we want the 40th percentile. So in other words, we're trying to find the index of our 40th percentile. So we'd use our formula, which is n, which is how many's in our data set, times what percentile we want. We want the 40th, so we'd use 40. Divide that by 100. We get 16.4. Now if I want to know the index of my 40th percentile, since k is not an integer, I go to the next greatest integer, which would be 17. Again, not the normal rounding rules. Now suppose that we have, let's look at another example. So we have 30 ordered values and we want the 20th percentile. Our n is 30, our p is 20, we use the formula. And this time we come with an integer. The integer is 6. So in order for us to get the 20th percentile, we're going to need to take the mean value of our 6th and 7th position. So if our a, so whatever the index is, we take that data value and the one greater than it, and we actually take those values, add them together, and get their average. So we take this general way to find percentiles and use it to find the quartiles, noting that the first quartile is just the 25th percentile and the third is just the 75th, and of course the second is the 50th. So if we want to find Q1, that's the 25th percentile, this is the formula that we would use. 25n over 100, which we could just reduce to n over 4. Now if k is an integer, then the first quartile would be the mean of the kth and the k plus 1 data values. To find the third quartile, it's 75n over 100, or 3n over 4. So in order to find the value of the third quartile, if k is an integer, then we take the kth and the k plus 1. If it's not, just like we did with percentiles, and this is the same for Q1, which I didn't mention, if k isn't an integer, then we go to the next greater integer. And you'll see on this sheet this k in brackets plus 1. That means the integer value, just the integer value of our whatever we have. We lop off the decimals, and that's what that means. We're looking at that k in brackets denotes the greatest integer less than k. So if k is 1.01, then we're looking at 1. Okay, if k were 3.25, if we put that in brackets, then we're looking at 3.